All right. So now in part two, we're going to get really hands-on with SQL. Um, I've got the curriculum pulled up here because we're going to refer to it as a guide in a couple points, but we're going to talk a little bit about Postgres and SQL. We're going to spend a good amount of time we're going to look at some sample data and actually design a schema for it, and then actually write SQL tables. And we'll see then how to run SQL files and import CSV data in Postgres. And when we're importing CSV data that has primary keys, how to deal with that, and then a bit more about how to modify fields and stuff. So let me talk real quick about Postgres and pSQL. Postgres is a database engine. The full name is PostgreSQL. Everyone just calls it Postgres. We installed it during InstallFest. There are a number of different ways to install it. We actually have it installed with the dev containers and assignments as well, if anyone's using Docker containers or dev containers. And Postgres is actually running its own little server that's listening for database connections, and all sorts of programs can connect to it. And I'll draw a diagram for this in just a moment. pSQL is one way to talk to Postgres. On the command line here, if I type which Postgres, we'll see some information about the Postgres app that I've installed. Um, I can actually see some info on it. I'm not sure if Postgres info will work. We can see which version is installed. pSQL is installed when you install Postgres. And it's an interactive command line program to talk to the Postgres server. So actually, to go back to one of our earlier diagrams, here we go. If we look at this sort of really big picture architecture, as a programmer, I can run the pSQL program on my computer to talk to the Postgres database engine running on a server somewhere else over the internet. Now, what we are doing in this course is we have Postgres and pSQL all running on the same thing, right? I've got my computer, and Postgres is installed and set up as what's called a service, which means that the computer starts it up automatically when the computer starts. And Postgres is running on port 5432, I believe. And I could have many different programs on my computer talking to Postgres. I could use pSQL. I could also have, excuse me, I could also have a Python program. And maybe that program is a Flask server or a Django server. And I could even use, if I wanted to, there are web tools like pgadmin, or you could even use, I'm sure there's a VS Code extension if we searched around. That would also talk to Postgres. So there's a lot of different ways that I can talk to Postgres on my computer. Um, and remember, the goal is that at some point, Postgres is not running on my computer. It's running on some other server. But I can still use any of these programs, but we're going to focus on the pSQL command line program to talk to Postgres. So two separate programs, and I just wanted to emphasize that. Alex, yes, sir.
Will we be learning at all how to connect to a Postgres server that's not running on our local computer?
Yes. We're not actually going to do it, but I will show you how right now. And then later in the course, depending on what you all do with your personal and group projects, you may actually do it then. Yeah, good question. And actually, let's check that out right now. Oh, apologies. I was muted. Thank you, Alex. I was saying, actually, let's check that out right now. Um, and so just to recap, Postgres is a standalone database server. I have it running on my local machine on a specific port, and it manages databases, tables, Postgres users, and everything else related to this. And because Postgres does all the work of figuring out where that data on my file system should be stored, right? Postgres takes care of this part of the data model called the physical data model. As a programmer, I just have to think about this and this, right? And so this is sort of like high level design. And then this is my actual uh, writing SQL to make tables. But in terms of where does the data live on my file system? How many copies of it does Postgres make? How do I make sure that that data isn't deleted? All of that stuff, by design, the Postgres server or the Postgres engine takes care of for us. And so pSQL can talk to Postgres. We can run them on the same machine or on different machines, and we have a little diagram here. Um, and if we break this down, let's run some of these pSQL commands. So if I just type pSQL by itself, it actually connects me to Postgres. I'm actually connected to a database named AdamC right now as the user AdamC at port 5432. Um, now, pSQL, now that it's running in my terminal over here, it's a little arcane. The pSQL commands start with this forward slash question mark. Will give you a list of all of them. On a practical level, we have a couple cheat sheets, and there are some online. The most important command, though, is of course /q for query. Um, so when I type that pSQL, it's actually inserting a lot of things for me. What was really happening under the hood there is pSQL -h for host, and by default, it will connect to the computer that pSQL is running on, my local host. -U for user. And we have this written down in the curriculum, not only here, but down at the bottom and in other places as well. So you don't have to worry too much about writing this down. U for username, and it was using my system username, or for WSL2 users, your Linux username by default. And then pSQL was connecting to a port, and by default, it will connect to port 5432, which is Postgres's default port. And then finally, it was connecting to a database. And by default, it will try to find a database with the same name as your system username. So when I went ahead and typed pSQL all by itself, under the hood, it was actually doing all of this. And these are its sort of default values. It was connecting to host, localhost. It was connecting as Postgres user AdamC, same name as my system user. It was connecting to Postgres on port 5432, and it was connecting to a Postgres database named AdamC, also the same name as my system user. And if I wanted to connect to a different database, now I have to know that that database exists. We see this connection error, and it says fatal database does not exist, does not exist. Now, from doing this in the past, I know that I have a database named school, so I can connect to that database. When you Postgres, you actually the Postgres engine uses a Postgres database to manage things. So there is always a database named Postgres. You don't really want to mess around with this Postgres database, but it does exist. And so to answer the question of if I wanted to connect to Postgres running on a server over the internet, how would I do that? I would replace localhost with the IP address or host name of wherever this Postgres server was running. I would need to make sure there's a Postgres user here. Postgres is probably running on port 5432, and I would need to know the database name. Then I could go ahead and run it. This is going to fail because I just made up that IP address. I have no idea what's over there, much less if Postgres is running. You might need to add the -w flag to type in the password related with your Postgres user when connecting to a remote host. So to do this, obviously you would need some information about that Postgres. And so if you're on a software engineering team, that information, it would probably be stored in like a password manager, or some of it might be stored, the non-sensitive parts in a README. But that's how you can connect to Postgres running in different places. So Postgres is the database server itself that creates different databases and so on. And again, we do have a nice cheat sheet here for all sorts of Postgres and pSQL and SQL stuff. Rick, yes, sir.
Yeah, it's a question. I'm not sure if we'll go over this at a later time, but whenever you're connecting to a Postgres server remotely, say it's Linode, AWS, wherever you got it running at, um, whenever when you have to connect to it from like Python or wherever you're connecting to it from, um, most Postgres servers require like like you were saying, like a password to be able to, add data, save new data, pull data, that kind of thing. Is and maybe something that we have to do like offline, but I've been told there's a way to embed those password authorization and authentications into your program, not in plain text, so that somebody can't just look at your program and go, "Oh, now I know how to get to the server." Um, I'm sure what we're probably not going to go over that kind of thing.
Yeah, we will go over that, but not right now.
Okay, all right.
Yeah, that's a really good point. If I've got a Python program, and I'm um, doing stuff, pretend this is code, and we're doing like Postgres dot connect, and oh, I don't know, we're doing host equals we have a and we're connecting to a Postgres host uh, on port 5432, and the user is uh, my program, and the password is my password, and the database name is, and we'll kind of put all this here just so we can see it. So you're absolutely correct that in my Python code, I do not want this password. Um, I might not want these other things, but that's less important. And we will learn later how we can write our Python code to grab password and other sensitive values from other places so that someone, if we, committed this code and pushed it to GitHub, someone could just look at our code in GitHub and see the password. But we'll see that when we get to Django. But it will make use of .env files. So with Postgres and pSQL, let's go ahead and let's do a little bit of actually schema design, and then we'll get our hands on some Postgres. And so there is some example data here in the curriculum, and I've kind of loaded it up here as well. And we are going to make a new diagram, and this data is for a game store. And if we look at this data, we can see what's going on. And so how do I turn a schema design into tables? What should my process be? So one, look at the data. This game store has employees. The employees have IDs, names, positions, salaries. This game store has games that you can buy. There's a game ID, a title, quantity, and so on. I'm going to look at this data in more detail later, but I'm just kind of looking at it at a high level right now. I can buy posters, right? I see that we have inventory information here for quantity and price. I can buy action figures. And again, I see quantity and price. And when I look at the data, I want to identify the entities. The main things I will turn into tables. And so, and this sounds pretty straightforward, but it's an important step and it's an easy step to skip. And let me go ahead and add a table, and I need to zoom out a bit. There we go. And so we know that our game store has employees. And here with this data organized in the CSV file, obviously it makes it a lot easier. But, you know, sometimes that's not always the case. We have games for sale. We have action figures for sale. And we have posters for sale. And let me zoom out a bit as well and kind of get our, I think that ought to do it. And we'll put the employees over here. We'll put the games and the action figures and the posters over here. So once you've looked at the data and you've identified the entities, look at the data again and try to identify relationships. So do I have any relationships between these things? Well, I see that, you know, there's quantities of posters and prices, so I know that customers can buy them. Same with games, same with action figures. But I don't see any sort of transaction data here. And I don't see any foreign keys, right? Like I don't see, you know, game ID or employee ID or anything that looks like it's identifying relationships between this existing data. So I am going to make a note. You know, customers can buy things. We will probably need a transaction table to track those purchases. And you know, each table of stuff to buy has inventory and price, right? Because there's quantity and price. But really, that's all there is. With employees, I see their salary information, but there's not much else. So there's not really any relationships. Once I've kind of looked for relationships, now I want to dig into the data for each table and identify primary keys. And in this case, that's pretty easy because we see that every single one of these has an ID column. Though actually here, if we look at games, I see there's a game ID. So it's not, they're not just calling it normal ID, but for posters, I see ID. For action figures, I see ID. So I'm going to go ahead and I'm going to make a couple of these ID columns. If you click here in your schema design, that's how you can tell it it's a primary key. And we're going to rename this to game ID. And then I've got posters. And after this, I want to look for and look for our columns, right? And I want to see what data type and what constraints I might need. And we're not going to worry too much about constraints right now. But so as I go through this, I see the action figure has a title, quantity, a price. Right. And this is, let's just make this text. And it has, there's how many action figures we have in inventory. And we see that we have a price. And the price is not an integer, right? It's got to be some sort of floating point number. And I think 2 decimal places is good. And I think every item needs to have a price. I don't want price to be null. And every action figure needs to have a title. And I don't want it to be null either. So I would then go through and do this for each of these different tables. Um, as we've kind of walked through some of this already, I think I want to kind of get to writing the actual SQL soon, but it is useful to go through each of these steps because this is where you identify things like, you know what, I see there's different positions here. Maybe I want to make an employee positions table to store this information. In case I have 2 employees with the same role, like maybe there's 2 IT specialists. So that might be a note that I make for later. Because as you dig into the data, you start to see important things like that. And so then once you've done this, we've used all this to construct a high level design, and we can use draw SQL or some tool like this. And it's good to do this first. And then finally, we can write SQL to create our various tables. Again, in the interest of time, I'm not going to flesh all of these out, but it's really this digging into the data where you start to think about your design and go through stuff. And we have here a sort of walkthrough of this, and you can see here just some visualizations of what the tables will look like. And I'm in fact going to just have this pulled up as I type this out just to help me not write typos. But we can see here that we're walking through each item and really thinking it through so that by the time I'm writing the SQL, I have a really strong picture in my mind of what things should look like. So I'm going to go ahead and I'm going to make a game store.sql file. And now I can go ahead and do this. And we'll talk about why we need to drop the table if exists a bit later. But in essence, this makes it easier to run the SQL file. And so I'm going to create this table. And let's name it, let's not make it plural so I don't lose my mind. And we have game ID, and it's an integer, and it's a primary key. We have our game title. And I'm going to do a varchar and let the game title be up to 255 characters, which is the max. I'm going to say that the game title has to be unique. So this is how you can add constraints. And I'm also going to say the game title can't be null. I'm going to give each game a quantity that's an integer, not a big int, which goes into probably the millions or probably the trillions, to be honest. Int is more than enough. It probably goes into the millions, and a price. And we're going to use the decimal type, and we're going to tell it how many characters and to what degree of precision. Right, so 999.99 is our max. Right, hot decimal length 5 with 2 degrees of precision. And I see a couple hands. Alex, yes, sir.
Can you quickly go over the drop table if exists again? I got confused about that last time. I thought it was to prevent duplicates.
Yeah,
Uh,
let's in fact, let's go ahead and run this SQL file and see this in action. So let me just go ahead and log into pSQL and let me create a database. And I can type pSQL commands in lowercase. You see it in uppercase just for readability. And we'll call this game store. And in fact, I see this error, database game store already exists from doing this in the past. So in fact, I'm going to have to drop this database. Drop is SQL slang for delete. And now I can create database game store. So my next step is once I've created my database, I want to tell pSQL to connect to it. So when I run this SQL, I will be running this in the game store database. If we look at this pSQL prompt here, I believe this shows me the database I'm currently connected to. And in pSQL, the /c command will connect me to a database. And indeed, we see the pSQL prompt has now changed. So I can write all of that stuff out by hand. It's tedious. But I can do it. And then when I add a semicolon, it will actually create that table. And now if I do /d to describe my database, you see we have this one table named game. And if I do /dt and give it the name of the table, or excuse me, -d and the name of the table, we see it's got this one column game title. That's not really what I want, right? I wanted to have all this nice stuff that I wrote in the SQL file. The way I run an SQL file from pSQL is I can use this /i command. Now, when I do this, I have to know the path to the file I want to run. So if I do /i.example/data/game store SQL, I think that should do it. And it looks like I got my path wrong. And it doesn't help that I have a typo. Let's fix that and see if that does it. So there's a couple issues that we're actually going to run into here. I'm not sure if I need the quotes, so I'm just kind of double checking here. Yeah, so there's a couple challenges here. For one, I need to make sure where I'm running pSQL from. For another, and let me go into the example directory. And from here, let's type print working directory. So here I have my full absolute path. And in pSQL, if I use a full absolute path, it should work. And indeed, we see that the game store was created. I see that the table was dropped and that the table was created. And if we describe our game table, we see it has what we want. Now, what if I change my mind and I decide I want to add another field, another column to this table? if I don't have this drop table and I want to update and build this table again using my SQL file, so I have an easy workflow of just using this /I command, watch what happens. We get this error, relation game already exists, which is P-SQL's way of telling us that this table already exists. So it's a really nice workflow to be able to write all of your SQL to create tables in one file. And then if I want to change something, I modify the file and I run it again. But one of the protections that Postgres gives us is if it doesn't let you overwrite stuff, I have to explicitly tell it, hey, I want to get rid of this table. So this is why I need the drop table if it exists in my SQL file. Does that help answer your question, Alex?
Yes, and I think it helped me understand slightly more if so the SQL file is not your database.
That's correct. The same way that the Python code is not my program. Like,
Got it.
like the Python runtime runs and executes that code. We are using P-SQL to pass this SQL to Postgres, and Postgres is executing it.
Got it. Okay.
Yeah,
Cool.
yeah, good question. Tom, yes, sir.
If we were to do this on an already existing database to modify a table like you were just using in your example, would this delete the data that's stored in a table?
That's
Or
correct.
okay, so would
Yeah,
would we need to create a new table, migrate the data, and then go ahead and delete?
yeah, that's basically correct. When you run
Okay,
this drop table, whatever data is in that table is also deleted. So we'll actually see how to alter an existing table later. But yeah, you're correct. If I have a table that has data that I want to modify, I do not want to drop the table. I need to modify the existing table, or like, which is probably the easier path than building a new table and migrating the data over it. Though sometimes you
get,
might need to do that.
got it.
Yeah,
Yes.
definitely. For like when you're developing a database, not once it's like running and live and being used for real. This is also why having fake data in CSV files is so useful, because if I'm just like developing things and working on it, it's way easier to have a bunch of fake data, just delete my tables and then just rerun my SQL and reload the CSV files. And in fact, this is what we're going to see. And later in Django, we'll see this with something called fixtures. But yeah, that's a great question. Um, I do want to see if I can't get that relative path working for me. And so I think part of the issue I was running into, and let's try to connect to that database game store, was when you're trying to run SQL from a relative path, um, I have to be really, it matters where I run P-SQL from. Like now that I navigated into this example directory, if I'm trying to run an SQL file, the relative path from where I ran P-SQL is, well, I ran it here in example. So game store is in fact right in the same file. And now that works. So you can use relative paths with this /I command to. All right, there we go. So recording stopped for a sec. Where we left off was we were talking about this /I command. This /I command is how you run an SQL file. We saw, and I'm hitting the up arrow here to go through my command history, that I can run it with an absolute path just fine. And I can run it with a relative path as well, but I have to know what directory I ran P-SQL from. And so I was in the example directory, and this is where I'm running P-SQL from. And so now my relative path is just /game store, and that should be the correct relative path, and I can run the code. So on a practical level, this is going to be the easiest way to do it. And again, if you kind of just run everything from your main project directory, then it should work fine. Like if I move up a directory here and we do pSQL and I do /I example game store SQL, that runs just fine before my relative path was wrong. So I recommend on the command line just getting really comfortable doing everything from your project's root directory, which is almost always where this README file is. So similarly, let's go ahead and let's make our other tables, and then we will import our CSV data. So honestly, when I'm writing SQL, I like having guide code up for me to see because I'm not great at remembering things, and there's a lot of duplicate code here. So I'm just going to do a split, and we're going to keep on writing our tables. So we're going to do drop table if exists, and let's do our action figures next. And we'll do create table action figure. And I know it's going to need an ID. And at this point, I actually don't remember what's in the action figures. So let's pull up that CSV and take a look. So we have action figure title. And when you're importing CSV data, it is going to be easier if you just have your column names be the same as what's in the CSV file. You can do it differently, but this will make things a bit simpler. And this I'll also make a var chart. And let's say, again, up to 255 characters. Quantity will also make an int. I know that the action figure title, I think I want it to be not null, and let's just say unique as well. So each action figure title has to be unique. That's going to be a design decision that I'm making. And then we have price, and I'm going to use the same price rule for all of my items. And now I have an action figure. And if we just keep on going through this, we see up next is a poster. And this code is really similar. So at this point, I'm actually going to do a little bit of copying and pasting. And this is poster title. And I see that quantity and price are the same. And so now I've got my game store, or excuse me, I've got my action figure, I've got my game, I've got my poster. I just need my employee. So I'm going to, again, copy and paste my guide code. Change this to the name of my next table, which is going to be employee. Employees will also have an ID, but let's see what else our employees need. Well, they need a name. And I'll decide that the employee name has to be unique. They don't have quantity, they have a position. Position will not be unique, but it can't be null. And they have a salary, which by looking at the data here, I see that there's 2 decimal places, but there's certainly more than 5 numbers, decimals total. I see 1, 2, 3, 4, 5, 6, 7. If someone made 6 figures, then we would have an extra here. So let's add some room to maneuver, and let's say that our decimal number can have 6 up to 8 places in it, and 2 places of precision. So 8.2 allows for highly paid employees like, you know, like that. So now I have what should be all 4 of my tables. Right, and let me go ahead and run my SQL. And it looks like we have an error here. And this is a really common kind of error. SQL really needs you to have that semicolon at the end of each statement. Otherwise, from SQL's perspective, for instance, I forgot it here, I forgot it here, I forgot it here. From SQL's perspective, all of this, everything without the semicolon is one big statement. And so there's all sorts of crazy syntax errors. For instance, if I add the semicolon here and run it, we'll see we still have some errors. Right? And we now see a different syntax error. But the problem is not with that line of code. The problem is with the missing semicolon. So this is by far the most common mistake in SQL. So it's important just whenever you have an error, if you're running SQL from pSQL, the first thing you should do is look for any missing semicolons. And again, you can see how that drop table is really useful for my coding workflow. And now we see that tables were dropped and created. This statement here is totally fine. Notice table action figure does not exist, skipping. That just means since this statement says drop table if exists, it doesn't worry about if the table doesn't exist. If I get rid of that statement, it will work, but it's better practice to have it exists there. I actually have to check to see exactly what safety checks it provides us, but it gives us a little bit of extra safety. So I just want to pause and check in here and see what questions folks have or what might be good to go over before we start working with the CSV files. Tom, yes, sir.
I'm pretty sure I know the answer just for verification purposes. It would be server side and program logic. I'm thinking, but like if we wanted to split the employee name into first and last, that's where it would need to be done, right? We can't do it in the schema.
That's a great question. So we totally could. I would just want to then, it would look like this. You can write SQL that will grab this CSV data and split this up into two separate things. I'm not going to go into that now as it does add a bit more complexity, but it is totally doable. That said, most of the time you're correct that we would actually probably do this in our Python code before we even get to this point.
Got it.
Yeah, yeah, good question. You can write SQL to do that. It just takes a bit of extra work. Yeah, great question. And in fact, let's see how to import the CSV data now. And this is definitely the simple way. So I am actually going to, I'm going to run this command from pSQL. And again, it's important that I know my relative path. And let's start with the game data. And let me pull that up here so we can see it as reference. So I'm going to use this command copy. And I'm going to tell it the table I want to copy to. Now I'm giving it the relative path to where I want to go. Oh, and I'm already in the example directory. So let's just do /data/game.csv. And now this next part is important with CSV header. And what this line is telling pSQL, and let me actually make one change here, because this actually does not need the slash. This is actually an SQL command. So I could actually put this command in an SQL file and run it. And in fact, we'll do that in just a minute. This with CSV header is telling Postgres that this SQL file starts with these headers. The CSV file starts with these headers. Because not every CSV file does. You totally can have a CSV file that looks like this. And then we would have to add some extra logic telling Postgres the name of each column. But with this, when I run this SQL command, Postgres will just it will look for columns that have the same names as these headers. And this error is a pretty tricky one to spot. And the issue here is I did games plural, but the name of my table is game singular. So indeed, a table named games does not exist. Let's try this again. So, I apologize, guys. I may actually have gotten myself confused here with the P-SQL and the Postgres. And I think we have a minor typo in our curriculum that we need to fix. Let's see if this does the trick. So let's see here. I'm getting close, but I think I must have a simple error here. Let's do a quick search here because I'm pretty sure this is a syntax issue. So probably not in. I just want to see if they have an example here. And I might just use the AI. Here we go. So this P-SQL command, copy table name to, and I don't think the format is the issue. I think the issue is my path. And let me take a quick look at my guide code here to see if we can get this sorted out. And this stuff is always a little persnickety, I will say. Like I always have to have some guide code up on this one, but I think we can get this one fixed in just a moment. So I'm going to do a couple things. And that's my problem. Okay, so this is where the relative paths used inside P-SQL can get a little tricky. I thought but I was running P-SQL from inside this example directory, and I was not. And this is why it's really useful to always do stuff the same way every time because stuff can just get confusing. So let's try this one more time. Copy game from example slash data slash game.csv with CSV header. And we see, so this is actually progress because the copy command tried to do its job. We hit this line that says error, invalid syntax for type integer 3999. And that is in fact this first value here in our game data. And so if I look here, and let me close this sidebar out so we can see 39.99. And if I look at price, so price is a decimal. So that should be working, but this is telling me that something has gone wrong because I've tried to somehow, I think, put 39.99 probably into the quantity field. So let's see if we can resolve this one. Chris, yes, sir.
Hey, Adam, I might drop something in the chat. It's from our previous, I think it's probably the third week when we were doing students database.
I see. Let me give that a shot. I don't think this is going to resolve it, but it certainly can't hurt.
What, Adam, I think you have for example purposes, I think you created a something column. I don't know if that's inside of your game table.
Oh, I totally did. And I think that is what's causing the issue. So I was looking at this. Yeah, because the error, I don't think Chris, if I need to, I'll come back to that, but this would make sense. Because if we run the command, there we go. So when we see this error, invalid input syntax or type integer 3999. So the first thought I had was maybe I screwed up with the type of column that price is, but I didn't. I set price as a decimal. So what's happening is when Postgres tries to input each of these column values basically in, it's getting the ordering wrong. And somehow this one is not going into price, it's going into probably quantity, which is an integer. And it's trying to put this 3999 into an integer. And this extra something field would indeed cause that, right? Because then like quantity would get shoved into something. And because it's a varchar and we're inputting from CSV, it probably accepts 30 just fine. So I could be wrong, but Alex, I think you may have identified the issue. And if we look at our game table, we see we've got this something field. So let's go ahead and delete that. And let's go ahead and run the SQL again. And so all of that runs. And just for fun, let's look at the game table. I don't see something there. And now let's try running this command again. So we would do copy game from, and now we do example data game.csv with CSV header. And now indeed it works. And this line is telling us that it's copied 10 items in. Alex, thank you very much, because I definitely would not have caught that. And just for us to kind of like verify, we can use a query statement, a select. So let's look at all the rows and each column from each row from our game table. And here we see our 10 items, right? And if I just wanted to see, say, the game title, I would say select just game title from game. If I wanted to see the game title and price, I would do it like that. Tony, yes, sir.
So yeah, I guess my question is, if you're not using a delimiter, does it automatically assume it's a comma when you're working with CSV?
Yeah, I'm pretty sure, because
Okay.
that's almost always the default delimiter.
Got it.
Yeah. Tom, yes, sir.
Yeah, I was just gonna piggyback off of that. That's actually what we did last time is you have to specify delimiter if it is anything other than a comma. Because I replaced all mine with slashes just for trial and error the last time, and it threw errors unless I specified that delimiter.
Yep. Yep. No, that makes sense. Yeah. No, so Chris, I appreciate the suggestion there. And it just points out there's often many different ways to get the same error, right? And I'm gonna put this here in our code. And let's actually see if we can't so this should run the psql command to import this CSV file into our table and create rows of data. And let's just go ahead and do this now for our action figure. And I'm going to go ahead and run my SQL to make sure that this is working. And we see copy 10 twice. And if I do select star from action figure, We see the action figures. And let's do this again for our poster. Yeah, and again, thank you guys for help with the debugging. As you can see, there's always a lot of moving parts. So sometimes it's easy to get zeroed in on the wrong thing. And I forgot, speaking of getting zeroed in on the wrong thing, I want to change this from action figure to poster. And this is also why this drop table is useful, right? It just makes it really easy for me to add stuff and modify it as I go. And let's go ahead and change that to poster. And this one actually should be action figure. And then this last one is employee. And now if we run our SQL, everything seems to work, but let's double check. Let's do select star from employee. We see our employees and everything looks good. Let's do select star from poster. We see our posters. Select star from game. We see our games. Select star from action figure. And we see our action figures. So now we're really cooking, and we've seen a nice workflow for using CSV files and headers. Let me show you guys how to do alter tables. And I realize we're running a bit long, so let me kind of, I think, just cover this part a little more quickly, and then we'll wrap by seeing how to modify a table to have primary keys. Well, actually, we can look at the primary key issue first because it may come up for other things. So let's take a look at our action figures table. I'm going to go ahead and clear this, and let's do D for describe. So there's a couple interesting things here. We see this ID column, action figure title, quantity price, and then we see these indexes. And Postgres actually created these indexes for us, and they're used for different things. Here we see this one was created for the action figure's primary key to keep track of it. And this second one is for unique constraints. The issue that we have is that I want to be able to maybe add a new action figure. And I would really like it if my action figure primary key could be auto incrementing. And let's go to action figure, and let's change this from int primary key to serial primary key. And let's go ahead and run this. And excuse me, let's get rid of and try it one more time. And now if we look at our action figure table, we see something interesting for this ID column. And let me grab our sort of annotator. For this ID column here, it says type integer, but its default value here is this. It almost looks like a line of code, right? Next value, action figure ID sequence, and then something about a regular class, I think. And so what I can do with this is I should be able to now like create a new action figure. And I would do something like, and let's pull up our action figures so I can get the field names right. Action figure 4. We'll just put 3 of them and we'll put them at 1099.
You have a typo in figure.
Yeah, in the double quotes.
No, FI. There you go.
Yeah, that shouldn't be the issue. I think maybe I might just have my syntax wrong here. I think it actually goes like this, action figure title, quantity, price, and then values. And we'll just say figure 4 and quantity 10 and price 10.99. Um, let's see, column figure 4 does not exist. My apologies. Let me do a quick.
Yeah, I don't know if it's the reason, but like in the action figure CSV, the name is not in print or not in quotes. I don't know if if putting in quotes is confusing it.
Yeah, it shouldn't be. I should be able to do insert into action figure. And now I give the column names, and we have action figure title, and then we have quantity, and then we have price, and then I say values, and let's just say figure 4 and 10 of them for 10.99. And this is what I wanted to get to. So my apologies. I had some sort of syntax error, but this error of duplicate key violates unique constraint primary key. This is a little tricky what's going on here. And what's going on here is when I modified my action figure table and I changed its ID from int to serial, what Postgres does is it basically makes a sort of auto incrementing list and it uses that as the default value for ID. So if I don't manually set that ID value, Postgres will just use the next number in this list that starts at 1, kind of like a Python range. But the problem is because our action figures already have IDs, these two things are out of sync. So this series or this serial thinks it's starting at 1, but there's already something there with the ID of 1 because we manually inserted these ID values. And we really want to use auto incrementing for our primary keys because it makes life a lot easier. But because of this issue, if we're importing CSV data that has these IDs, there's a bit of an extra step we have to take to do it. Right. And again, just to kind of illustrate the command, here is the command I ran. And if I had manually passed in an ID instead of setting a default value, it would have worked just fine. If I said ID and let's put in an ID value that we know doesn't exist. Like if I put in 1, which already exists, we see that same error. But if I put in 11, it inserts just fine. So the solution to this is a little bit magic. It's definitely not something that you guys need to master. It may just come up once or twice as you work on problems. And also it gives us a chance to dig a bit deeper into Postgres and learn a little bit about the idea of a sequence and how to update things. And give me just one moment here. My system is telling me that it's having a memory issue, so I'm closing some stuff out. Okay, and that ought to do it. So the steps I have to run, and I'm going to put them in the code so that it's easier for us to see. The steps I have to run look like this. I have to drop the existing auto increment sequence. I have to create a new ID auto increment sequence. And I have to update the next value in the sequence. And to do this, we're actually going to have to alter our table. And we're going to actually alter our column ID. And we're going to set its default to the next value of our action figure ID sequence. And we're actually going to have to add one more command here, which will actually do the updating. And this is getting a little fancy with our querying. We're writing a subquery here, and using Postgres has a lot of functions, which we'll learn about tomorrow. So we're getting the maximum ID value. From our table. So there's a bunch of steps we have to run here. And let me close a couple things out. There we go. But now what this should do is let us be able to use this serial primary key and import our action figure data. And actually, we should do this copy command first. Once we've imported our CSV data, we need to update the ID auto increment sequence. So this is, again, a bit more advanced and a bit more magic, and that is okay. And let's see here. To roll back the current transaction because another process aborted, blah, 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 blah. So it looks like I might have got kicked out of pSQL. And it looks like my Postgres server might not be running. Sorry, my computer seems to be doing something funny here. Give me just a minute. I'm going to close a bunch of things out. Somehow, I think it's the number of video files I have on here was eating up memory, and it stopped a couple things. I think I've restarted Postgres now. Yep. And we're connected to our game store. There we go. And now let's try running that command. Let's try running our SQL. And we see, let's see, error cannot drop sequence action figure ID sequence because other figures depend on it. Detailed default value for column ID. Use drop cascade to drop the dependent objects. So because something else depends on this, and it is probably the action figure table, it does not really like this. So I may need to add the cascade, as it was saying. And let's see if this does it. If this doesn't do it, I may just debug this offline. And let's see. And it looks like I just need to put the cascade at the very end. And we'll talk more about cascade tomorrow, actually. But basically, because this table depends on this, it's probably dropping. It doesn't want to drop it. So cascade tells it it's okay. And in fact, it might be dropping the table. And let's see if we have anything in here. And so we have these action figures, and let's see if my insert statement works now. If I go kind of way back up, let's go ahead and insert into our action figure without using an ID and see if this works. And so now that command does indeed work. And I'll put this in our example code too. And so there were a couple steps, but now we can see that automatically that ID of 11 was created. And again, we are only going to have to worry about this if our CSV data already has IDs in it. So this is very much a special situation. We did get to see a little bit of altering tables. So this is the alter table command that we used. It is relatively straightforward to use. You could do it here in pSQL if I wanted to alter the poster table. And let's make it just a varchar. And if I look at my poster table, I see now I've added this column, right? On a practical level, it's probably easier to write it in your SQL code. And then similarly, if you want to modify a column, it's the same syntax. For instance, let's modify our something column. And let's set data type to be an int. Now, if I have data in here, it will complain and it won't let me do that. But without any data, it should work just fine. And then finally, you can drop individual columns, and you can drop whole tables. We've seen constraints a bit already. This not null constraint that we've seen up here. We also have a unique constraint up here. Primary key is actually a constraint. And we'll learn more about that tomorrow. And then this we've already really covered, but we do have here in the curriculum a breakdown of that Postgres connection URL, which we could alternatively pass to SQL instead of on the command line doing pSQL-U and -H and all of that. We see that what we have here is username, password, host, port, database name. Right? So in our Python code, this connection string is probably what we would use. And then here are just a couple sort of helper commands. So just to recap, and I know we ran a bit long here, but we saw how to look at CSV data. We saw steps for going through it step by step to build a data schema. starting with a schema diagram to flesh out. And then we saw how to write an SQL file to create that data. We saw a workflow that we can use to iterate and continue developing on it. We saw a little debugging along the way, and we saw how to import CSV data. And then finally, we saw how I can set up an auto incrementing primary key, right? By using this serial column type, and then this command to update the sequence that Postgres uses to do its auto incrementing. So that we've gone pretty deep into Postgres, and in our next lesson tomorrow, we will look more at sort of designing databases and constraints and columns and stuff. Let me go ahead and stop our recording, and then we can pause for questions and stuff.